Suppose these two series are both convergent, show that the squared value of this infinite terms is convergent. Okay, የመጀመሪያውን part እናያለን። ምን ተሰጥቶናል? It's given here this infinite series, okay, starting from 0 up to ak is convergent ተብሎ ተሰጥቶናል. This is convergent. Okay, if this series is convergent, the partial sum of this series will also be convergent. So let Sn be the partial sum of the given series. Let Sn be the partial sum. N is equals to k ak. Partial sum will be on a1 plus a2 plus up to an the partial sum of the given series. Yes, the convergent series partial sum beyond. Then since this series is convergent, since the infinite series ak is convergent, a convergent notable selection. Since this is convergent, the limit of the partial sum Sn as n approaches to infinity converge ያደርጋል ወደ ሆነ number n, where l is some positive number, right? So ይህንን እንይዝና now consider this thing. Now consider this fact. Consider we always have a1 square plus a2 square plus a3 square up to an square. This is less than a1 plus a2 plus a3 and so on, the whole square, where all the terms are positive. For any positive terms, ይሄ እውነት እንደሆነ እናውቃለን. So using this fact, we can rewrite this thing like the summation of the partial sum k starting from 0 to n ak square is less than, this is strictly less than the partial sum. ምክንያቱም ይሄንን Sn ብለን represent ስላደረግን, so the partial sum square ይሆናል ማለት ነው. So we know this fact. Since the series is convergent, since this series is convergent, we can have limit on both sides. The limit of this partial sum k starting from 0 to k is equals to n ak square as n approaches to infinity is less than the limit of Sn as n approaches to infinity. This is L square. Okay, ከዚህ ምን observe እናደርጋለን? This limit is less than L square. ምን ማለት ነው? ይሄ the sum of the infinite series k starting from 0 to infinity ak square is less than some number L square. So we can say that the sum or the infinite series k starts from 0 to infinity ak square is convergent. Converge ያደርጋል ማለት ነው. Is convergent. Okay, because it's bounded above by a certain number L square. Okay, አሁን ወደ ሁለተኛው ፓርት እንመጣለን። ወደዚህኛው ፓርት ስንመጣ አሁንም የምንጠቀመው የተሰጠንን ኢንፎርሜሽን ነው. These two series are convergent ተብለናል. So if these two series are convergent, we can say that given the terms of the series, የሁለቱ series terms ak እና bk የሚባሉ ተርሞች አሉ. So these terms are given such that there exists sufficiently large number n for all k greater than n. For all k greater than n, ak is greater than or equals to 0, bk is greater than or equals to 0 due to the convergence of the two series. እነዚህ series which converge ያደርጋሉ ስለተባለን we can start by saying this statement. So we want to show that here ማሳየት የፈለግነው ምንድነው? We want to show that the series AK times BK K starting from 0. By the way, ከ0 ይነሳ ከአንድ difference አይኖረውም. K starting from 0 to infinity is convergent. ይሄንን ነው ማሳየት የፈለግነው. Convergent. So we have these two convergent series. We want to show this fact. ይሄን ነገር እናሳያለን. So now take n prime which is greater than or equals to capital N that we have here assumed such that K is strictly greater than capital N prime. This leads us AK is less than or equals to 1. እንደዚህ ማለት እንችላለን. ይሄንን ስቴትመንት የምንልበት ምክንያት this AK is less than or equals to 1 የምንልበት ምክንያት sum of the series AK ምን ስለሆነ converge ስለሚያደርግ ነው. ኦኬ ይሄ converge የሚያደርግ ከሆነ obviously AK should go to 0 ወደ 0 approach ያደርጋል for any n or for any K is big. Okay, so this works for all K greater than capital N prime. Okay, so due to this fact ይሄንን ማለት እንችላለን ማለት ነው. So እንዲህ ካልን we have here the absolute value of AK times BK is AK times BK because all the terms are assumed to be positive. This is less than or equals to BK because this AK is something less than or equals to 1 slanted. So this can be the same as the absolute value of BK. Okay, ይሄ ምን ይነግረናል ማለት ነው? The absolute value of AK times BK is less than or equals to the absolute value of BK. So this works for all K greater than or equals to 0. So this implies the summation. We can take both sides by the summation. So this is the same as the absolute value of AK times BK, which is less than or equals to the summation of BK, K starting from 0 to infinity. አሁን ምን እናውቃለን? ይሄ convergent ነው. So we can have the summation of AK times BK, K starting from 0 to infinity is bounded above. It is bounded above. Therefore the series AK times BK, K starting from 0 to infinity is convergent. So ሰባተኛ ጥያቄ ላይ test the convergence or divergence using alternating series test ነው የሚለው. So ምንድነው የምንጠቀመው? Alternating series test ተጠቅመን converge ወይም diverge ማድረጋቸውን እናያለን የነዚህን series. So by definition ለማስታወስ ያህል the series minus 1 the power of n can be starting from 1 up to infinity. ይሄ converge ያደርጋል የምንለው this converges if it satisfies this condition. One is the limit of the nth term as n approaches to infinity 0 መሆን አለበት. The other thing the terms of the series እያንዳንዱ terms order ስናደርገው decreasing መሆን አለበት. Okay, so እነዚህን ሁለቱን ካሟላ the given alternating series ይሄ alternating series converge ያደርጋል እንላለን. So let's see the first part. A ላይ ያለውን series እንይ. The series minus 1 the power of n times n over 5n minus 2 n starting from 1 up to infinity. Okay, አሁን እዚህ ጋር የምንወስደው an ብለን የምንወስደው ይሄንን part ነው. So our an is n over 5n minus 2. So the limit of this term, an as n approaches to infinity, ምን ማለት ነው? The limit of n over 5n minus 2 as n approaches to infinity ምንድነው የሚሰጠን? 1 over 5 ነው። ይሄ ደግሞ ከዜሮ የተለየ ነምበር ነው. It will not satisfy the first condition. Therefore, by alternating series test, therefore this series diverges. Minus 1 the power of n over 5n minus 2 ይሄ diverge ያደርጋል ማለት ነው. Similarly, let's see the b part. b ጋር ያለውን series እንይ. In b the series is minus 1 the power of n times radical n over ln n as n starts from 1 up to infinity. It's certain. So here our n's term is root n over ln n. Okay, here now n's term actual. So limit to evaluate another garden. So the limit of root n over ln n as n approaches to infinity is, this is infinite over infinite, therefore we use L'Hopital rule. So using L'Hopital rule, the limit of root n derivative over ln n derivative እንጠቀማለን. So this becomes the limit of root n derivative ማለት 1 over 2 root n ነው. ln n derivative ደግሞ 1 over n ነው as n approaches to infinity. So this becomes the limit of, simplify ስናደርገው, this becomes the limit of root n over 2 as n approaches to infinity, which is infinite. ምን መሆን ነበረበት? The limit of an as n approaches to infinity 0 መሆን ነበረበት. Okay, ይሄንን 0 መሆን ነበረበት. ይሄንን አላሟላ. So this is infinite. So the series minus 1 the power of n root n over ln n diverge ያደርጋል ማለት ነው. የመጀመሪያው ፕሮፐርቲ ማሟላት አልቻለም. So diverge ያደርጋል ማለት ነው. Test for absolute convergence, conditional convergence or divergence for each of the following. Okay, እዚህ ስምንተኛ ውስጥ ሶስት ሲሪስ አለን. The first one is k from 2 up to infinity minus 1 the power of k over k ln k ነው የሚለን. So explicitly ስንጽፈው this becomes 1 over 2 ln 2 minus 1 over 3 ln 3 plus 1 over 4 ln 4 እያለ የሚቀጥል ሲሪስ ነው. So you can check that this is convergent series no by alternating series test ይሄ series converge እንደሚያደርግ ቼክ ማድረግ ትችላላችሁ. So by taking ak is equals to 1 over k ln k ምን ማሳየት ይቻላል? the limit of the k's term as k approaches to infinity 0 መሆኑን ማሳየትና the terms of this series ak decreasing መሆኑን ማሳየት በቂ ነው. So if we are able to show this thing, obviously the given series is convergent using alternating series test. Okay, alternating series test convergent መሆኑን ቼክ አደረግን. Now let's take the series in the absolute value minus 1 the power of k over k ln k በአብሶሉት value ውስጥ ስናስገባው ምን ይሆናል የሚለውን ነገር እናያለን. So this is exactly the same as, this is the same as the summation k starts from 2 up to infinity 1 over k ln k no mihono. So this series is divergent using integral test. This is divergent by integral test. By integral test. ምን ማሳየት ብቻ በቂ ነው the integral from 2 up to infinity 1 over x ln x ምን መሆኑን ማሳየት ነው infinite መሆኑን ማሳየት በቂ ነው so this is exactly the same as the limit of ln x we evaluate this thing from 2 up to n where n is approaching to infinity. Okay, so this becomes infinite, therefore this series is divergent. So alternating series test ተጠቅመን converge ያደረገው series absolute values እናስገባው diverge አድርጓል. Therefore the given series minus 1 the power of k over k ln k starting from 2 up to infinity is conditionally convergent. Conditionally converge ያደርጋል ማለት ነው the b part ወደ b ስንመጣ we have a series n starting from 1 up to infinity minus 1 the power of n times n over 5n plus 1. Okay, we have this. So let's take this in the absolute value, the summation n starting from 1 up to infinity in the absolute value minus 1 the power of n times n over 5n plus 1. 5n plus 1 is the same as the summation n starting from 1 up to infinity n over 5n plus 1. Okay, ይሄን ይሰጠናል absolute values ስናስገባ. So here we have an አለን. So the limit of an as n approaches to infinity ምንድነው የሚሰጠን 1 over 5 ነው which is a number different from 0. So ይሄ divergent series ነው ማለት ነው. This diverges. Okay, therefore the series minus 1 the power of n times n over 5n plus 1 ምን ይሆናል ማለት ነው divergent ነው ማለት ነው. It's divergent. Okay, the C part. When we come to the C part, we have a series n starts from 1 up to infinity minus 1 the power of n minus 1 times n plus 10 over n times n squared plus 1. Okay, now let's see what it looks like. The series in the absolute value minus 1 the power of n minus 1 times n plus 10 over n times n squared plus 1. This can be the same as the summation n starting from 1 up to infinity n plus 10 over n times n squared plus 1 ነው የሚሆነው. So ይሄንን ቼክ እናደርጋለን ኮንቨርጀንት ነው ወይስ ዳይቨርጀንት ነው የሚለውን ነገር እናያለን. Now since n plus 10 by n times n squared plus 1 is strictly less than n over n times n squared plus 1, this is less than 1 over n into n squared plus 1, still this can be written as less than 1 over n squared for all n. ይሄ ሁሌም true ነው የሚሆነው። አሁን ምን ልጠቀም ነው ማለት ነው ሊሚት ኮምፓሪዝን ቴስት ልጠቀም ነው። So this implies the summation n plus 10 over n times n square plus 1 is strictly less than the summation 1 over n square ይሆናል አሁን እዚች ጋር ማየት ያለብን this series is convergent it's convergent by p series ይሄ convergent መሆኑን እናውቃለን so if the bigger series is convergent obviously the one which is below will be convergent n plus 10 by n times n square plus 1 converge ያደርጋል ማለት ነው okay it converges therefore the given series and starting from 1 up to infinity minus 1 the power of n minus 1 times n plus 10 over n times n square plus 1 is absolutely convergent This is also infinite series which can be written as እንደዚህ ተብሎ የሚገለጽ series ነው n starting from 1 up to infinity minus 1 the power of n plus 1 times 2n minus 1 over 3n this is the series that we are going to check ይሄ diverge ያደርጋል ወይስ converge ያደርጋል የሚለውን absolute convergence or divergence እንጠቀማለን so let's take the absolute value of this series n starting from 1 up to infinity in the absolute value minus 1 the power of n plus 1 times 2n minus 1 over 3n ይሄ ምን ይሰጠናል this is the same as the series 2n minus 1 over 3n ይሆናል እዚህ ጋር አሁን ይሄንን terms of a sequence or a series እንወስዳለን an is equals to 2n minus 1 over 3n so let's evaluate this limit the limit of an as n approaches to infinity የዚህን ሊሚት ስንሰራ ምን ማለት ነው the limit of 2n minus 1 over 3n as n approaches to infinity this is 2 over 3 which is a number different from 0 ከ0 የተለየ ቁጥር ነው so the limit of the n term ከ0 የተለየ ከሆነ በምንም ተአምር ያ series converge አያደርግም so this series diverges the series minus 1 the power of n plus 1 times 2n minus 1 over 3n diverges so this is divergent using absolute divergence or convergence test so this diverges so እዚህ ስምንተኛ ጥያቄ ውስጥ እስከ ዲ ያለው ሰርችላችኋለሁኝ ብዙ ነው ውስጡ ያለው ዝርዝር so roughly ይሄን ይመስላል ስምንተኛ ጥያቄ